Hi guys, so earlier in the course we learned about the concepts of load balancing, and what I'm going to do now is introduce to you the Amazon Elastic Load Balancing service. So this is Amazon's service for load balancing with Amazon EC2, and you can also use it with other services which we'll learn about later in the course, including the Elastic Container Service ECS for Docker containers, and also the AWS Lambda service, which is a function as a service example. So how does this work? We have our users connecting to our Elastic Load Balancer, and then they get routed to a EC2 instance. And those EC2 instances can be in different availability zones, so they're different subnets in different AZs, and that means that we have that sort of fault tolerance for our instances. And all these connections get routed, and then what happens if something fails? Well, in that instance, the user is then connected to a different instance in the back end. So that's seamless to the user. When that happens, the ELB will also take the instance out of service because it fails what's called a health check. So the Elastic Load Balancer is constantly checking the health of these instances, and it does so by making a connection to them. And we can configure the port and the protocol and the path to use for that health check. So it keeps checking the EC2 instance to make sure it's still there and it's running. And if it is, then it keeps it in service. And if it's not, then it takes it out of service and it knows it can route the connection somewhere else. Also, it can communicate to autoscaling that this has happened. And autoscaling can then take that instance out of service or terminate it, and it can then launch a replacement instance. And then if another user came along, they might be able to connect to that instance. So that's how it works in theory. Let's have a look in practice and set this up on AWS. Now, by the way, this architecture does include high availability and fault tolerance. So we've got our instances spread across different data centers because they're in different availability zones and different subnets. So that means that if one AZ fails, then we've still got instances in another one. And we can automatically route our connections to those instances. We can also recover from failures of instances because auto-scaling will automatically launch new instances. And we have the elasticity we want in that the auto-scaling group will launch additional instances whenever we need them, and the Elastic Load Balancer will make sure that the connections reach those instances. So it's a pretty cool setup, and we're going to head over to AWS now, and we're going to build this out. The first thing we're going to do is set up our Elastic Load Balancer. So to do that, we go to EC2, we come down to Load Balancers, and this is where you can create your load balancer. So I'm going to choose Create Load Balancer. There's three different types. So there's an Application Load Balancer. This is the one that operates at the HTTP and HTTPS level. That means it directs connection requests based on information here like the domain name or the path in the URL. We then have the Network Load Balancer, which operates at the TCP level. It's a bit different. And then we have the Classic Load Balancer, which is an old generation and it's being deprecated. We're going to choose a Application Load Balancer. I'm going to call this My ALB. Under Load Balancer Protocol, it's going to listen on HTTP. So if we're running a website, it's going to listen on port 80, which is the port on which your website will run. For VPC, we leave it at default, and then we can select the availability zones we want to connect to. And we just choose a subnet in each of these, and it's auto selected those subnets for me. Let's go down, click on Next. It's just warning me that I don't have a secure listener. HTTP is port 80, and it means that the data is clear text, it's not encrypted. Whereas if you had a secure listener on HTTPS, which is port 443, that's when you're using SSL TLS encryption. So we're going to go Next, click on Web Access for our security group, and then we go to Routing. And here we're creating something called a target group. And this is where our actual EC2 instances are going to be running. I'm going to call it TG1. I'm connecting to instances. You can also connect to IP addresses and Lambda functions, but in this case, we're going to be launching some EC2 instances. We leave all these as defaults. Click on Next. We don't have any targets to register yet, so we just go to Review and then Create. And that's it. Our load balancer is now being created for us. So soon we're going to create an auto scaling group and we're going to launch some EC2 instances, and they're going to be behind this load balancer. So we're going to attach our target group to our auto scaling group. So the first thing I need to do though is we just need to head over to Amazon S3, and I'm going to create a new bucket. So this is going to be the bucket which holds some files which are used by some user data that we're going to create for our EC2 instances. You'll see why soon. So I'm going to call this dct-user-data lab, and hopefully that's a bucket name that's free. Now if you can't find your bucket name, sometimes just add a few characters afterwards and that will make it unique, and that's good enough for the purposes of demonstration. So I'm just going to see if this one is free, and it is. Let's go into our bucket, choose upload, add files, and in the course download under code and files you'll find this directory called website. And what you need is just two files, the index.txt and the names.csv. So just select those two, click on choose, and then click on upload. So we now should have our files. Let's see, the last one's just finishing off there. And now we've got our two files. So one of them is the index.txt. That's actually going to become the index.html file, which is the document used by our website. And then this one has a list of names. And what it means is it's going to give our instances names. And therefore, on the web page, we'll be able to see the name of the instance, which helps with load balancing because we'll be able to see which instance we're connected to. So now we can go back to EC2, and we're going to create another launch template. So what we did earlier, we went to launch configurations. It actually redirected us to launch templates. So let's go here. This is the newer way of creating a template for use with an auto scaling group. So we click create launch template. I'll call this one LT1 because it is a launch template. We'll just scroll down to Amazon machine image. We've got to find the Amazon Linux 2 AMI. So this one here. The instance type, I'm going to type t2.micro, and we've got the T2 free tier eligible micro instance. And let's come down, VPC is correct, security group, let's choose web access. And then let's come down a bit further, and under advanced details, firstly, we need to choose our S3 read-only IAM role. So remember, this is what's going to give us the permissions to access S3. So when these instances launch, they're going to actually use this role to access those files that we just uploaded to our bucket. And we need to add some user data. So this is the user data we're going to add. It's in your code and files directory. And it's a little bit more complex than before. The first part is the same. It's going to create a website. But then what it's going to do is in this bit here, it's going to copy the files from our S3 bucket, and then it runs this command at the end. It's actually two separate commands, and you need to make sure that that's the case. So I'm using the Visual Studio Code editor here, and we can see these all separate lines. Sometimes if you copy this into a Word document, for example, and then copy it from there, you might lose the line break, and it thinks this is one line. So make sure you've got separate lines. I recommend using an editor such as Visual Studio Code. So the last command, what it will do is it will actually find a name at random from this file and then add it to the index.txt file and rename it to index.html. So you'll see the result. You don't need to edit any of this except for the bucket name. So what we need to do is find our bucket name and just add that in there. So mine was dct-user-data-lab. So just make sure that you edit this to your bucket name because mine probably won't exist by the time you do this. So I'm just going to put that in here and here. So now we've got the code, and I'm going to copy, come back to here, paste in my user data. So now all of that user data from the bin bash at the beginning right through to this last command here, that should all be pasted in. Let's click on create launch template. So that's done. We've now got launch template 1. Let's come back down to auto scaling groups. Create an auto scaling group. Going to call this ASG1 again. We're going to choose LT1 and let's click on next. It's going to stay in that VPC. We can add in multiple subnets so that we have instances in different availability zones. Click on Next. And in this case, we're going to enable load balancing. And we can use the application load balancer that we already created. And the way you attach a application load balancer is by attaching its target group. So let's add the target group. We can add the ELB health checks as well, which means the Elastic Load Balancer will notify autoscaling if it thinks that an instance is not working correctly. So that's in addition to the EC2 status checks. Let's click on Next. Let's put our desired capacity and our minimum and our maximum. We're just going to keep these all at 4 for the moment. We won't attach a scaling policy at this point. Let's click on Next, click on Next, Next again, and then come down and create our auto scaling group. So that's going to now launch those instances. It will add them to the target group for the Elastic Load Balancer, and then we should see that the Elastic Load Balancer can then be used to connect to these instances. So give it a few minutes. It does need to initialize all the instances, install and update the Apache. So our website is running, and then they need to be registered and become healthy with the load balancer as well. So there's a couple of places you can monitor this. Clearly you can go into auto scaling. We've seen this before, and see what's happening here. We can see 4 instances have been launched. We can also go to load balancers, and there's a couple of places here. So we can go to target groups, click on the target group, click on targets, and we can see that there are 4 targets, and they're in the initial status. We need them to be in the healthy status before we're going to be able to connect to them. So hopefully they're going to launch and become available. You can also go into monitoring here and see some detailed information. The other thing you can do is go to load balancers, and with your load balancer selected, you can click on monitoring and you get monitoring information for the load balancer. So I'm going to go back to target groups and keep an eye on what's happening here. And I want these to become healthy very soon. So that was really fast, and they've now become healthy. So I've got 4 healthy instances. So what I can do is go to load balancers, come back to the description here, and this is the DNS name for the load balancer. You don't see the IP address, but you get the DNS name. So I've copied that to my clipboard, and I'm going to go to a new tab, paste in that, and you can see that I'm connected. And so this is what that file did. It says that my Amazon EC2 instance's name is Vela, and it pulled that name at random. So let's see what happens if I refresh. Now I go to Blake, then Dean, then Raylin, and it's just going to keep cycling. So what's happening there is I'm refreshing my page, and as I do so, the load balancer just keeps sending the new connection request to a different backend instance. So I'm actually load balanced across the different instances. So that's it for this lesson. We're not going to do any scaling. If you wanted to, have a bit more fun with this, you could add a target tracking policy as we did before, and then have it automatically adjust to any load that you apply using a utility like Stress. But for now, what we're going to do is we're just going to terminate this configuration. So the way to do that, in load balancers, we can just click on Action, Delete. The target group doesn't cost you anything, so it's up to you. I'm just going to go in and clean mine up. So I'm going to delete that one. With our auto scaling group, we can come in and click on, select the item here, and then click on delete, and we have to type delete. And that's going to then delete our instances as well. So if you just watch here, I think it's always worth checking. So even though it should delete the instances, sometimes it can fail. So just always have a look and make sure, because you don't want to leave 4 instances running. In this case, it has shut them down successfully, so they're on their way down now, and that means we're not going to pay anything. So I hope you enjoyed that, guys. See you in the next lesson.